Today we shall study about current electricity. In current electricity, we study about electric current. The charges in motion constitute an electric current. Means the mobile charges form an electric current. Mobile charges compose electric current. We shall study about a steady current. The flow of charges in lighting is not steady, but water flowing smoothly in a river, a torch, and a shell-driven clock are examples of a steady current. Imagine a small area held normal to the direction of flow of charges. Both the positive and negative charges may flow forward and backward across the area in a given time, the interval t. Let q be the net amount of positive charge that flows in the forward direction across the area. Similarly, let q be the net amount of negative charge flowing across the area in the forward direction in the time interval t. Q barabar q or minus q. This is proportional to t for steady current, and the quotient I barabar q by t. It means charge per unit time. It is called current or electric current. So it is not always steady, and we can define in the following way. I is a function of t, and I function of t is equal to limit delta t tending to 0 delta q by delta t, where delta q is the net charge flowing across a cross-section of a conductor during the time interval delta t. Then current at time t across the cross-section of the conductor is defined as the value of the ratio of delta q to delta t. In limit of delta t tending to 0, in SI unit the unit of current is ampere. In CGS unit the unit is ESU or electrostatic unit. 1 ampere per 3 × 10 to the power 9 ESU. Now Ohm's law. As shown in the figure, a conductor is a cross-sectional area A and length is L. Imagine a current flowing in a conductor of length L. Let V be the potential difference between the ends of conductor. Then Ohm's law states that V proportional I. It means potential difference is proportional to current, or V barabar Ri, where the constant of proportionality is called resistance of the conductor. SI unit of resistance is ohm, denoted by symbol as shown in the figure. The resistance R not only depends on the material of the conductor but also on the dimension of the conductor. Let the cross-section area be A of the conductor, then R proportional L by A and R barabar L dash rho L by A, where the constant of proportionality depends on the material of conductor but not on dimensions. Rho is called resistivity. इसलिए V बराबर rho L by A into Y. Now the current per unit area Now the current per unit area, take a normal to current, taken normal to current, I beta A is called current density. It is denoted by J. The SI unit of current density are ampere per meter square. Further, if is the magnitude of uniform magnetic field in the conductor whose length is L, then the potential difference V across the end is EL. Now EL बराबर J rho L, इसलिए E बराबर J rho. In vector form E बराबर J rho और J बराबर sigma E, where E बराबर sigma बराबर 1 by rho called conductivity, drift of electrons and origin of resistivity. What is the drift or motion of electrons and what is the origin of resistivity as shown in the figure? An electron will suffer collisions with the heavy fixed charge, but after collision it will emerge with the same speed but in random directions. If we consider all the electrons, their average velocity will be zero since their directions are random. Thus, if there are n electrons and the velocity of the ith electron I barabar 1, 2, 3 dash dash n at a given time is Vi, then 1 by n summation Vi I barabar 1 to n barabar 0. Consider now the situation. Consider now the situation when an electric field is present. Electrons will be accelerated due to the field A or minus E by M, where E is the charge of electron and capital E is the electric field, M is the mass of electron. Where E minus E is the charge and M is the mass of electron. Consider again the ith electron at a given time. This electron would have had its last collision sometime before T and T1 be the time elapsed after its last collision. If V1 was its velocity immediately after the last collision, then its velocity V1 at time T is Vi barabar Vi minus capital Vi barabar small vi minus E bata M Ti. The average velocity of the electrons at time T is the average of all the Vi. The average of Vi is 0 since immediately after collision the direction of the velocity of an electron is completely random. The collision of electrons do not occur at regular intervals. At regular intervals of time, let us denote by tau the average time of successive collision. Then at a given time some of the electrons would have spent time more than tau and some less than tau dash. The average value of tau is known as relaxation time. Thus, over the n electrons at any given time t gives us as for the average velocity is Vd barabar Vi average barabar Vi average minus E by m tau barabar 0 minus E by m tau barabar minus E bata m tau. It tells us that the electron move with an average velocity which is independent of time. All the electrons are accumulated. This is the phenomenon of drift, and the velocity Vd is called the drift velocity. as shown in the figure, delta x बराबर Vd delta t and electric field is shown. Hence, the amount of charge crossing the area of A in time delta t is by I delta t, where I is the magnitude of the current. So, I delta t बराबर NE/AYV delta t. Tau NE/AYV delta t. Substitute the value of Vd from equation 1 we get I delta t बराबर E square A/m tau n delta t E. By definition, I is related to magnitude J of current density by I बराबर J. Hence, J बराबर NE square by m tau E. NE square tau E by m. हो गया. The vector J is parallel to E, and hence we can write in the vector form J बराबर NE square बटा m tau E. That is equation number 2. Equation 2 is exactly the Ohm's law. Thus we can say that J बराबर sigma tau E, where sigma is conductivity is equal to NE square by m tau. इसलिए J बराबर सिग्मा E, where सिग्मा बराबर NE square by m tau. Thus we see that a very simple picture of electrical conduction reproduces Ohm's law. Mobility, conductivity arises from mobile charge carriers in metals. These mobile charge carriers are electrons in an ionized gas. They are electrons and positive charge ions. In an electrolyte, these can be both positive and negative ions. An important quantity is the immobility mu, defined as the magnitude of the drift velocity per unit electric field mu बराबर mod Vd by E. The SI unit of mobility is meter square per volt second and is 10 to the power and to meter square per volt second and 10 to the power 4 of the mobility. In practical units, centimeter square per volt second. Mobility is positive. We have Vd बराबर tau E by m. Hence mu बराबर Vd by E बराबर E tau by m.